Part A of this question asks us to find the probability that the counter in the bag is not blue. According to the table, there are then 30 blue counters, and it says here that there are 100 counters in the bag. So we can find the number of counters that aren't blue by taking it off 100. So I'm going to do 100 minus 30, then it gives you 70. So there are 70 counters that are not blue. We're looking for the probability that the counter is not blue, so it's going to be the number of not blue counters, which is 70, over the total number of counters, which is then 100, so it's 70 over 100. It doesn't ask us to give it as a fraction in its simplest form, so we can just leave it as that, as a 70 over 100, but if you did simplify it, you could simplify it to 7 over 10. The ratio of the number of blue counters to the number of green counters is 2 to 3. So blue being 2 and then green being 3. Work out the number of green counters in the bag. So we're told in the table here that 30 of the counters are blue. And I'm going to put that directly below the 2 in that part of the ratio just there. So 2 parts in that ratio then represents the blue counters, which is 30. So in order to go from 2 to 30, we then multiply by 15, because 30 divided by 2 gives you 15. We're now going to multiply the 3 green parts by 15, and 3 times 15 then gives you 45. So that then tells us that there's 45 green counters in this bag. Bradley says the number of red counters in the bag is the same as the number of yellow counters in the bag. Can Bradley be correct? Give a reason for your answer. So there's 100 counters in total. We're then going to take off the 30 blue ones and the 45 green ones, and when you do that you then get 25. So that then tells you that the red and the yellow must add up to 25. He says here, so the number of red counters in the bag is the same as the number of yellow counters, and both of those must add up to 25. If they're the same, we would just divide that by 2. And when you divide 25 by 2, you get 12.5. That's not an integer, therefore he cannot be right, because you can't have a part of a counter. In order to find out the wording for this question, just have a little look at the mark scheme, because that will then tell you what is or what is not acceptable for this question. But I would say something along the lines of 25 divided by 2 does not give you a whole number of counters, therefore he is wrong.